Good morning to all of you. We continue with the arrays, double dimensional arrays. We continue with the double dimensional array. Now, with the yesterday's topic, we have seen the use of index numbers I and j, and we have calculated the highest element. Previously, we have calculated the sum of each row and each column, then we have found out the highest element. Is it? Now, though you can easily assess the indexes now. Index can be easily assessed by you, but now from today, today we will be trying to print the left diagonal, right diagonal of a matrix, or together the left and right diagonal. You can find out the sum of left diagonal, sum of right diagonal. So we move on today with the printing of sum of finding the sum of left diagonal, and then we will be finding a sum of right diagonals also. And this is to be done today, and homework for you is that you people should try to print the left diagonal and right diagonal, how it will get printed up. I need to suppose 3 by 3 matrix is there, 3 elements here, 3 elements here, 3 elements here. Then you have to print the cross x in x, the elements which are present there. This is called as the diagonal elements. The element which start from the left to bottom, it's the main diagonal of the, or the left diagonal, and which starts from right to the left, it is the right diagonal. So today we will be dealing with the left diagonal and the right diagonal, and for that again the index numbers are the must. How you will utilize the index number with the loop, you have to learn the utilizations of the index numbers. If you are easily you can adjust with the index number, then everything is easy for you. Today, so we will again today also we will plan out first and try to understand what it is, and then we will convert it into the program. Let's move on with what I mean. So today we are going to calculate first the sum of left diagonal, sum of right diagonal, and the next question we will be printing out the two diagonals also. Thank you. Let's proceed now. Now what I mean here, if suppose you are having a diagonal, this is now this is an array I0 1 2 0 1 2. Suppose the elements are there 2 3 4 5 6 7 8 9 10. Now we need the sum of this, the left diagonal. This is the left diagonal, 2 plus 6 plus 10. Is it? We need to find the sum of this. So what it is now, 2 6 8 10 18, and we need to find out the sum of this, the right diagonal, 4 plus 6 plus 8. Is it? So 10 18 now again. Now what is how to find out this now? Now this is 0 0, this is 0 1 0 2 1 0 1 1 1 2 2 0 2 1 2 2. Is it? Now we need to find the elements in the left diagonal. Now what is the elements now here for the left diagonal? This is I, this is j, this is I, this is j, this is I, this is j. When a left diagonal formation is there, when I is equals to j, is it or not? When I is equals to j, I is also 0, j is 0, it will print I is 1 and j is when 1, then only it will find the sum. When I is 2 and j is also 2, then you can find the sum. Is it? So left diagonal can be found out like this. But when we move on with the right diagonal, now this is 0 2 1 1 2 0. Is it? How can we find it out now? Now, when I is 0 and j is 2, when I is 1, j is 1, when I is 2, j is 0. That means this j is decreasing. This can be one technique. So we take a counter for, instead of j, we take a counter k. K equals to n minus 1. This is column n minus 1. N minus 1, that is n is 3. 3 by 3 na? 3 into 3 matrix it is. 3 into 3 matrix. So 3 minus 1, k is 2. So I0 k. We can have I0 k2. We will get the first element. Is it? Then k minus minus. I becomes 1, k becomes 1. So we can get this. Then again I increments to, k decrements to 0. We get this. It is one way of finding a right diagonal. This is how we can find the right diagonal. Now what can be the another way? The another way can be, what is? If I plus j equals to n minus 1. Look now here. I plus j equals to n minus 1. This is for the right diagonal. This is first technique. This is the second technique for the right diagonal. I plus j equals to n minus 1. Now I0, then j will become 2. 0 plus 2 equals to 3 minus 1. 3 minus 1, what is 2 na? 2. So 2 equals to 2. 0 plus 2, 2. Now 1 plus 1, 2. 2 plus 0, 2. So this is how this is another way by which you can find it out. This is another way. You can find out the right diagonals. So we are going to practice. It out. Practice out. This is the second. Oh, I missed the left diagonal. This is I equals to j I had done. Suppose we run a single loop only for I equals to 0, I less than m, I plus plus. SOP, A of I can be. I00, then it will print. I becomes 1 1, then 1 1 gets printed. I becomes 2, then 2 2 only gets printed. So this is another way. So we are going to practice out both ways. We will be practicing both the ways when how it can be done. So first one, this one, IJ, and this one we will be practicing out, and then in the second method we will be practicing out both ways. So let's continue. Import java.util dot asterisk class ABC void main scanner. System.in. What you require? We require I, J, M, N, and I, J, M, N is required. M into N matrix, है ना? Let it be M into N matrix, or if it is say, M into N. And you require a left diagonal, you require a right diagonal. These are the two requirements which we have. So let the left diagonal equals to 0 and right diagonal also equals to 0. Get the row limit, enter the row limit or size, whatever you can say. M equals to sc dot next int method, then supplement enter the column limit, n equals to sc dot next int method, create an array, int array equals to new int mn, and then enter the elements. For I equals to 0, I less than m, I plus plus. For j equals to 0, j less than n, j plus plus. Enter the elements. A of ij equals to sc dot next int method, you close. The array is ready now. Now what we need to do? We have to find the sum. So how we are going to find the sum? Let's implement a simple logic with it. For I equals to 0, I less than m, I plus plus. So here we are going with the left diagonal. So left diagonal equals to left diagonal plus a of ia. Is it? So plan sum of left diagonal plus LD. You got the left diagonal here. Now we need to have a, as I said, you need to have a counter. Let's have a counter here, counter k, and k equals to n minus 1. Are you getting it? So run a loop again. For I equals to 0, I less than m, I plus plus. So right diagonal equals to right diagonal plus a of ik, and k minus minus, or k equals to k minus k equals to k minus 1, or k minus equals to 1, whatever. We are decreasing it out. So plan sum of right diagonal plus RD. Close the main, close the class. I 0 0 1 1 2 2. It will get it error. Now here I 0 है, k की वैल्यू कितनी हो गई 3. Suppose 3 by 3, then it is 2, तो 0 2, then 0 1, then 1 0, then 2 0. I बढ़ता जाएगा, k घटता जाएगा. Now I equals to 0, k equals to 2, so it prints 0 2. Gets added up, then I value changes to 1, then k changes to 1. So a of 1 1. then I changes to 2, k changes to 0. So a of 2 0, is it 0 2, this one, then 1 1, you got the 1 1, then 2 0, you got the 2 0. Now the second method. So second method remains as it is. Import java.util.string class abc void main scanner sc equals to new scanner system dot in. You require int I j m n left diagonal right diagonal. This is what the requirement is. Then supplen enter the row limit m equals to sc dot next int method, then supplen enter the column limit. Handwriting is very good, na? I will be receiving an award. N equals to sc dot next int method, construct an array, int array equals to new int mn. Here you have a arrays mn, then enter the element. For I equals to 0, I less than m, I less than n, I plus plus. Now ld equals to 0 and rd also equals to 0 here. For j equals to 0, j less than n, j plus plus, enter the elements a of I j equals to sc dot next int method. Yeah. And now for I equals to 0, I less than m, I plus plus. For j equals to 0, j less than n, j plus plus. Here you need to find the if. What was the condition? If I is equals to j, it is, then you are going to find the sum. If I equals to j, then rd left diagonal ld equals to ld plus a of ij. Is it? This is one. If I plus j equals to n minus 1, then rd equals to rd plus a of ij. This is what done here. And supplen sum of left diagonal plus ld sum of right diagonal plus rd. This is how you have to do it. Now you can use an internal message system. One thing was very good. Somebody has worked out with an array, single dimensional array in his system, and he got an error and he reported it me through internal messaging system of our portal, SJS Campus Care portal. So I had answered him, and many of them have subscribed the channel and they are sending it me through my inbox. Then also I try to reply it with reply to them in the next video. If you people have any doubt, those who are studying, and I had watched many are not studying, it's a worthless better than if you don't study. because it's take a very lot of time, my lot of time. I had to set, I had to record, then I had to merge it, then I had to upload it. It takes a lot of time for me. It's easier to teach in a classroom, but it's really difficult to go through this online. It's a time consuming, as well as battery consuming. It consumes the net packs, so it becomes worthless if you don't study. And remember one thing, that it is impossible to carry out these programs again in the class, because syllabus is really very big and I had to cover others also. If the school opens, there is a very less chance that it gets open very quickly, because you people are much educated and aware. It's going to take a time, and then we will have to push out with the other activities, other syllabus. We don't have the time to teach it again and revise it again. Maybe an overview, if possible, we will be going with it. So please discuss it. Please take it very seriously. Prepare for your board. And look, now the programs are gradually getting difficult and difficult. Please go through it. Please work it out. And if you have any problem, you can write it to my inbox, or you can through the internal message system, and I will be replying it. Best wishes.